let's review factoring, right? Unit 8. But before we even go with factoring, we need to know how to simplify, which something like this. Like if I had an x plus 3 on the inside of parentheses with the 2 on the outside, I need to simplify this. What's the answer going to be? Anybody? Yeah, you distribute, right? It says 2 times the parentheses x plus 3, so the 2 gets distributed. The multiplication of 2 gets distributed. 2 times x is 2x, and 2 times 3 is 6. We all understand that, right? Okay, so this is even before factoring. This is distributed property. We already did that. Okay, how about this? What if we had a binomial times a binomial, like 2x minus 3 and 3x plus 1? And you need to distribute there because it's saying this binomial times this binomial. So how do we do that? We do the same thing. We distribute, but we distribute one at a time. So you would go 2x times 3x, and that would give you 6x squared. 2x times 1, that's going to be a positive 2x. And then you distribute the negative 3 times 3x, that's a negative 9x. And negative 3 times 1, that's a negative 3. And then, of course, you could combine the middle terms. You have 2, you owe 9, you're going to owe 7. So you have 6x squared minus 7x minus 3. And that's your final answer for that distribution problem. Now, believe it or not, there's a question like this on the final exam, right? Super easy. You have a binomial times a binomial, you distribute, okay? So we're not simplifying, we're not distributing on Unit 8, and what we're reviewing today. What we're reviewing is factoring. But what is factoring? It's simply doing distributive property, but backwards. It's like if I gave you the question 6x squared minus 7x minus 3, and I asked you to factor it, then you would have to come up with the original binomials that you multiplied with. Once again, factoring is doing distributive property backwards, and there's many types of factoring. You see, the very first type of factoring that we learned was pulling out the GCF. So if you look at this binomial, what's in common in the first term and the second term? What's in common? There's definitely a 3, and there's also x's. So 3x is the GCF. And then, again, factoring is just distributed property backwards. So if I were to distribute, 3x times what would get us back to that 6x squared? Or 2x, right? And 3x times what would get you back to a negative 9x? A negative 3, that's right. And that's factoring right there. That is factoring right there. Okay? It's just reverse distributed property. Let's move on. Because there's other types of factoring. Here's another type of factoring where we have a standard form quadratic trinomial, ax squared plus bx plus c, where the a value is 1. So when the a value is 1, when there's no number in the front, by the way, you have to do this on the final exam, when there's no number in the front, you could set this up, x, and you could think what times what is your c value that if you combine together is your b value, okay? Now, you could only approach it like this when there's no number in the front, because what is x times x? X times x is x squared. But if you had a 6 right here, or a 4, or an 8, then x times x won't give you 8x squared. Like it might be a 2 and a 4, or maybe a 4 and a 2. So if there's a number out here, you can't set this up. But because there's no number, you could do parentheses, x, and then think what times what is the c value. And I always say make a list of the multiples of negative 24 in this case. So I'm going to start with negative 1 times 24. Negative 2 times what? 12. Negative 3 times 8. Negative 4 times 6. And that's it. 5 doesn't work. Those are all the possible combos of multiplying numbers together to give you that c value negative 24. So the question is, which of these pair of numbers, when I combine them, no longer multiply. I made the list from multiplication, but now it's just adding them, combining them. Which pair of numbers, when I combine them, will give me the middle value b, which is negative 2? Well, 24 take away 1 is 23. That's not 23. 12 take away 2 is 10. That's not 10. 8 take away 3 is 5. That's not 5. 6 take away 4 is 2. That is a 2, but I want it to be negative. So I have the right number, just the wrong sign, which means I have the right numbers over here, just the wrong signs. You have to change that to a positive, that to a negative, and you plug them in right here, plus 4 minus 6, and that is factoring. That comes out on the final. Are you guys going to get that right on the final? I hope so. It's not that bad. Pretty easy. Now, there's other types of factoring also. When you have a number out here in the front, that's where it gets challenging, okay? And right here we have a number out in the front, okay? So it'd be a great idea to copy this down if you want to be ready for the final. So because there's a number out here in the front, you cannot do this. I said you cannot. Why not? Because x times x is not 4x squared, so you can't do that. You can't think what times what is c that if you add together is b. You simply can't do that. So what do? We have these steps that I have written for you right here. I also posted them on Google Classroom, so you could use them during the review and on the final exam itself. So steps to factoring the standard form ax squared plus bx plus c when a is not 1. So when there's a number out here like a 4, you're going to use these steps. And if you follow the steps, it's pretty easy. Step 1 is to multiply a times c, and you get a number. So what is step 1? Multiply a times c. What do I get when I multiply a times c? Negative 12. Thank you so much. That is the answer for step 1. Moving on to step 2. Step 2 says, make a list of the multiples of that number. Okay, let's make a list of the multiples of negative 12. So let's do that. Let's do the first part. Negative 1 times 12. Negative 2 times 6. Negative 3 times 4. Actually, that's it. There's only 3 possible combos, right? Now, which of these pairs of numbers, when I combine them, gives me B? So if I combine 12 and minus 1, that's 11. That's not 11. 6 minus 2, that's 4. And that is 4. So I don't have to change any signs or anything. This is my answer right there. Okay? Are you with me? So step 3. Once I find that pair of numbers, what do I do with it? It says plug those numbers into this format. A binomial times a binomial. So here we go. Step 3 is a binomial times a binomial. And notice it says ax and ax. So the a value is 4, so I'm going to put 4x and 4x. And I need to plug in the pair of numbers from step 2. The negative 2 and the 6 are going to go right in here. Negative 2, negative 6. No, positive 6, I'm sorry. Positive 6 or positive 6. And this looks like the answer, but it's not the answer, because if you started distributing 4x times 4x is 16x squared, not 4x squared. So far this is wrong, but that's why we do this fourth magical step where you just divide each binomial by whatever you can, if you can. So right here, the 4 and the 2, you could divide both of them by 2. So when you divide 4x by 2, you get 2x. When you divide minus 2 by 2, you get 1. And on the second one, you could also divide both of these by 2. So 4x divided by 2 is 2x, and 6 divided by 2 is 3, and voila, we have factored. That's as hard as it gets. I hope you remember that from Unit 8, or if not, I hope you understand it now so you could get it right on the final. Let's try one. Let's have you guys try one. Go for it. Step 1, a times c. What is a times c? Negative 18. Thank you so much. All right, step 2, let's make a list of the multiples of negative 18. That's negative 1 times 18. Or you could have done positive 1 times negative 18. It's totally up to you. I like doing negative 1, then negative 2, then negative 3, right? So what is negative 2 times what gives us 18? Negative 2 times 9. Negative 3 times 6. Negative 4 doesn't work. And that's it. There's only 3 combos. So out of these 3 combos, which one combines together to give us the middle value, negative 7? Well, this gives us 17. This gives us positive 7 when I add these together. So that's what I want, because I do have the number 7 here, but I want it to be a negative. And if I add these, it gives me a positive 7. So I have the right number, just the wrong sign. I have the right numbers, just the wrong signs. So change that, and that's the pair of numbers that we want. And what do we do with those pair of numbers? We plug those numbers into this format, ax and ax. So what is the a value in this problem? 6, right? So we're going to put 6x and 6x, 6x and 6x, okay? And we plug in the pair of numbers from step 2, the positive 2 and the minus 9 into those blank spots. And the fourth and final magical step is to divide each binomial by whatever you can, if you can. So like if this would have been a 6x plus 1, you can't do anything, you would just rewrite it. But 6 and 2, they both could be divided by 2. That's right. So what do I get when I divide both by 2? I get a 3x plus 1. Could I divide both of these by 2? No, I can't. I could divide both of them by what? By 3. That's right. So we're going to divide both of those by 3, and we're going to get 2x minus 3, and voila, we're done. Okay? We know how to factor. That's awesome. There's this other type of factoring, though. Like right here, we also don't have a number in the front. And right here, we don't even have a middle term. Now, you might be thinking, okay, let's go through the steps. Multiply a times c. I don't want to deal with 49 times 25. That's going to be huge. Forget about that. Forget about making a list of multiples right there. Whenever you have a number out here in the front, if it's a perfect square number, okay, there's that shortcut. When we factored, this was called factoring a difference of two perfect square terms, right? So if you have a perfect square term in the front and a perfect square term in the back, you might be able to square root them and then plug them into your factored format of a binomial times a binomial. So if I look at the first term, 49x squared, that is a perfect square term. In my head, the square root of 49x squared is 7 with an x. So you put 7x as the first part of each binomial. And then the square root of 25 is what? 5. So you put a 5 as the second part of each binomial. Now think about this. If we're distributing, 7x times 7x give us a 49x squared. But at the very end of your distribution, how are you going to get a minus 25? Well, one has to be a positive 5 times has to be a negative 5. So the signs have to be different. One has to be a plus, one has to be a minus. They have to be different. Not only that, there is no middle term, and the only way that the middle terms cancel out is if you have the same binomial, but one's plus and one's minus right in the middle, right? So this is the shortcut of factoring a difference of two squares. This is a perfect square quadratic binomial. This one over here might be a perfect square quadratic trinomial. You got to square root it, plug it into your factored format, but then you got to double check it, okay? So let's do that. We're going to square root the 16x squared. And the square root of 16x squared is 4x. So you put a 4x as the first part of each binomial. And then you could do the square root of 25, which we already did, was 5. Put that as the second part of each binomial. Now think about this. At the very end, what kind of 5 times what kind of 5 will give you a positive 25? Well, they're either both going to be positive, but then the whole thing would be positive, or they could both be negative, which you should conclude that they're both negative because a negative 5 times a negative 5 is a positive 25, and that's where the middle term being negative will come out. So that would be a minus and a minus right there. Minus and a minus, okay? Of course, you should double check it, right? 4x times 4x, 16x squared. 4x times negative 5, that's negative 20x. Negative 5 times 4x is another negative 20x. And when you combine them, it does give you that negative 40x in the middle. So this is the correct factorization. So not every single time that you have a number out here in the front, you're going to use that 4-step process of multiplying a times c and making a list. No. If you have a perfect square term in the front, perfect square term in the back, you might as well square root them, plug them into your factored form, answer format, and see if they work. Now you might be thinking, why the heck do I want to be able to do distributive property backwards? Why, if I have the answer, do I want the multiplication problem? Well, you see, if you actually have a multiplication problem and it's in an equation and it's set equal to 0, check this out. Right here we have something times something equals 0. And technically, this is like if it were factored form, right? Imagine you factoring something and you write your binomials and this is what you end up as your factored form. Once you get to here where you have something times something equals 0, you could use a zero product property and say that the first something, the x minus 3, that could be 0. And the second something, the 5x plus 1, that could also be 0. Okay, so once again, zero product property says if you have something times something else and it equals 0, the first something could be set equal to 0 and the second something could be set equal to 0. So what ends up happening is you end up with two simple equations that you could solve. Plus 3, x equals 3 is one answer, minus 1, 5x equals minus 1. You got to get rid of the multiplication of 5, divide by 5, x equals negative 1/5 is the other answer. And believe it or not, there is one equation like this on the final exam and on your review where you just split them, set them each equal to 0 and solve. Okay? That's simple. You write down both of these answers to get credit. Of course, on the final, it's a multiple choice. So you're going to see these answers as a multiple choice option. So again, we factor to be able to get it to look like this, so we could have something times something equaling 0, so we could split them and set them each equal to 0, so we could solve them nice and easy. So here's an equation, a quadratic trinomial equation, where the a value's not 1. So you might be thinking, well, we're going to have to do that long process of multiplying a times c, and you could do that, but whenever I see a quadratic trinomial and I could identify the a not being 1, the b value of 5 and the c value of -3, I would like to just fall back on the quadratic formula, because a quadratic formula always works. So what is a quadratic formula? Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And when you use a quadratic formula, it would be great to use it, rewriting it with parentheses first. And then you could easily plug in your b value of 5 right here and right there. You could plug in your a value of 2 right here and right there. And you could plug in your c value of -3 right in there. Okay? Now, when you're using the quadratic formula, I always say do the discriminant first. The discriminant is the value inside the square root. And you could do that on a calculator. I recommend you do it. It'll be safer. Or you could do it the way I'm about to right now. 5 to the second power is 25. I'm just going to write down 25 right here on the side. And then -4 times 2, that's -8. And -8 times -3 is a plus 24. So inside my square root, -5 plus or minus, inside my square root, I actually have 25 plus 24, which is 49. And it's still divided by 2 times 2, which is 4. Okay? Now, the beauty of this is the square root of 49 is actually the nice number 7, no more square roots. So what I end up with is -5 plus or minus the beautiful number 7, no more square roots, divided by 4. Now, the plus or minus actually means that you're going to get two answers. You're going to do -5 plus 7 divided by 4 and -5 minus 7 divided by 4. That'll give you two different answers. So let's write that down. -5 plus 7 divided by 4 and -5 minus 7 divided by 4. So -5 plus 7, that's 2. 2 divided by 4, you can't do that, but you could reduce, and that'll give you 1/2. And the other one, -5 minus 7, that's -12. And -12 divided by 4 is -3. And that's the other answer. So on this one, I use the quadratic formula to solve my equation. Now, if you're taking the final and you see that your multiple choice answers are not like nice numbers like -3 or like 1/2, let's say you see that there's square roots in your multiple choice answers, then for sure use the quadratic formula, okay? But if you do see that all of your multiple choice answers are nice numbers like -3 and 5, 2 and 7, 1 and 4, then you could factor, split, and solve, right? So I could solve this one by factoring, splitting, and solving. Does anybody want me to do that? Just go back and actually factor, split, and solve? Yes, please. All right, let's do it. So here we go. Check it out. Step 1 would be to multiply a times c. That would be 2 times -3. That is -6. Step 2, make a list of the multiples of -6. That's -1 times 6, -2 times 3. Then you ask yourself, which of these pair of numbers combines together to give us the middle value, +5? Oh, that would be the -1 plus 6. That would give us a +5. Step 3 would be to write your binomials, ax, ax. In this case, a is 2, so 2x and 2x. And you take that pair of numbers from step 2 and plug it in, a -1 and a +6. And the final step is to divide by whatever you possibly can. The first binomial, you can't divide by anything, so we're just going to leave it. The second binomial, you could divide by 2. If you divide 2x by 2, that'll give you a 1x. If you divide 6 by 2, that'll give you a 3. And now that's factored. Now keep in mind that this equals this binomial times that binomial, which means I still have the equation equals 0. So what I need to do now is set my factored form equal to 0 and continue solving. So I have equals 0, and now I could use zero product property. What is zero product property? 2x minus 1, that could equal 0. X plus 3, that could equal 0. If I solve both of them by adding 1, having 2x equaling 1, and then dividing by 2, final answer will be x equals 1/2. The other one, you simply subtract 3, and you get the answer x equals -3. As you can see, we get the same exact answers, -3 and +1/2. I just did it in 2 different ways. I wanted to show you all your possible ways of solving this equation using the quadratic formula or factoring, splitting, and solving. Okay? I think that's good enough. You guys look bored. Okay, I'm done.